In this lesson, we are going to be discussing how to graph sine and cosine functions. As we think of a unit circle, when the cosine graph is moving around the unit circle, it is going to actually graph what happens. So if you take the cosine function, remember cosine is the x value on the unit circle. As you move the x value around the unit circle, it is going to create a wave graph. Now, whenever it gets back to the beginning of the unit circle, where it comes to 2 pi, it will start over, which means the wave function will repeat itself. Now, the sine graph, we're going to go ahead and do the same thing. Let's go ahead and go back. Now, I'm going to get rid of the cosine. The sine graph, remember the sine graph is the y value. So as the y value going around the unit circle, it peaks up here for the y, and then it heads back to the x-axis on the unit circle, and then it goes down to -1, because remember, unit circle, the radius is 1, so it's only going to go up to 1 and down to -1. And then again, it will continue to repeat as it goes to 3 pi, 4 pi, 5 pi, 6 pi. They cross at pi over 4 because they are the exact same numbers at pi over 4. And then they cross again at 5 pi over 4 because they're both negative, same number at that point. And they cross like that. So here's what the sine and cosine functions will look like. If you were to continue to go through the unit circle forwards and backwards, which is why you can see if you're going the unit circle in the negative direction, it has the exact same type of wave function. Again, know that you're going from up to 1 and then down to -1. And it repeats every time you hit 2 pi. So you go up, down, and back up, and then after 2 pi, it completely repeats itself. The cosine function starts up here at the top, whereas the sine function starts at 0, 0. The cosine function starts at 0, 1. And then it goes down and then back up, and then it repeats itself again every 2 pi. So the functions are actually the same if you were to move them over. So like for example, if you were to start here and go down and back up, it would look like the cosine function. It's just moved over. So here's how you transform the graphs. It works for sine and cosine. The letter in front, that is your vertical stretch. So like if that's a 2 times sine, that means it would go up to 2 and down to -2. The inside function is the horizontal stretch and the horizontal shift. And then the outside number is the vertical shift. We will talk more about the horizontal stretch and the horizontal shift. The horizontal shift is if you were to set that inside parentheses equal to 0. There is one other way you might see this written as well. And it might be written as y equals a times sine of b, and then the parentheses x minus c plus d. In that case, c is going to equal the automatic shift. You don't have to set it equal to 0. It's automatically going to be the shift. And b is automatically going to be the period. And the period is actually a formula. So 2 pi over b. So for example, if b represented 2, so if you had like sine of 2x, for example, that means I'll do 2 pi over 2, which is pi. What that represents as a period is basically saying that the sine graph will completely do a full cycle every pi instead of every 2 pi. Again, the unit circle is 2 pi, which means sine goes up, down, and back up every 2 pi. But when you change the period, if there's a number in front, that means a full cycle is going to happen every other number. So for example, this is automatically, we're going to be graphing in radians. So let's change that to radians. So let's say that the amplitude is 4. And if you notice, here I'll show the base function. The base function goes up to 1, down to -1. But when you put a 4 in front of the sine, it stretches it up to 4. It still crosses at 0 in the same places that the original sine does. But the amplitude, the stretch, the top part and the bottom part will get stretched to that number. Also, if we made it negative, like -3, then instead of going up and then down, it actually goes down and then up. It completely reflects. And again, you go up to 3 and down to -3. The number in front, just like we said, you go up, down, and back to the original starting point every pi, and then you do it again. So basically what's happening, if you think about this too, basically that number is representing how many times you create a cycle inside of 2 pi, which means you should have 2 cycles inside of when it goes back to 2 pi. Again, the normal goes up, down, and back up to 2 pi. But 2 means you should have 2 cycles. So it goes up, down, and back to home base, up, down, and back to home base every 2 pi. The number, the shift, let's shift pi over 2. So what it's going to do, it's going to be the opposite. So let's do a minus. So the original is red, and it shifted over pi over 2 to the right. The top shifted over, bottom shifted over, everything, the entire graph moves over pi over 2. And then if you want to move the whole thing up or down, that number will tell you how many places to move it completely up or down. Same thing happens with the cosine graph. This is based off of y equals a times cosine of either bx minus c plus d, or the b could be on the outside. So in this case, there is the b, c, and d, there is no numbers, and so nothing happens. The only number is a, which is the amplitude, which means we would say that this graph stretches by a factor of 2. And if we wanted to actually graph it, so cosine goes down and then back up every 1 and -1. And so for 2, that means at 2 and -2, it is going to stretch. So again, in this vertical stretch, we are only dealing with a vertical stretch. And so we are looking at this number alone, which means it is going to stretch by a factor of 4 and reflect across the y, no, just kidding, across the x-axis. Now, a horizontal stretch, that is where you're going to use the period is going to equal 2 pi over b. So therefore, since this number is b, it is going to be 2 pi over 1/2, which is 4 pi. So that is a horizontal stretch of 4 pi. What that represents, if we were to graph this sine function, here's pi, 2 pi, 3 pi, 4 pi. Okay, a normal sine goes up, down, and back up every 2 pi. But this gets stretched out to 4 pi, which means it is going to go up, down, and back up every 4 pi, which means the whole thing stretched out twice as far. So another horizontal stretch, this again represents b, and a horizontal stretch is 2 pi over b, so it's going to be 2 pi over 3 is going to be the period. So you would say that this function has a period of 2 pi over 3. Now a phase shift is going left and right. So what you're going to do is take the inside of the parentheses and you're set it equal to 0, which means pi. So what you'll do is you'll say that this will shift to the right, because it's positive, pi units. In this case, you will have to make the entire parentheses set equal to 0, which means you'll have 2x equals pi over 3, which means x equals pi over 6, which means that you would say that it will shift right, again because it's positive, pi over 6. And then vertical shift, because the number is on the outside of the parentheses, that means you would say that it will shift up 2 units. In this case, you would say that it will shift down 4 units. So now let's bring it all together. So again, we have a times sine of bx minus c plus d. 5 represents a. The number in front of x represents b, which means that it is a 1. And we'll set it, and then 3 equals d. So we would say that it has an amplitude of 5. That is number 1. Or you could say that it will stretch by a factor of 5, either one. The second part is going to be the horizontal stretch. The period is what you're looking for, which is going to be 2 pi over b. And because b is 1, that means the period is 2 pi, which is what it's normally. The original parent function is going to be 2 pi. Number 3, we're going to set the parentheses equal to 0, which means we're going to add pi over 2 to both sides, which means that we will say that it will shift right pi over 2. And then 4, d is 3, so it will be a vertical shift up 3.